So here is our example, which is the AAA company example. And the first thing that we have to start out with is define what is X and what is Y. So for us, X is local payroll in $100 million. So you have to describe it fully. So it's not enough to simply say local payroll or X is independent variables. You have to describe what it is. And Y is AAA sales in $100,000. And we have a random sample of 6 observations, historical records. Okay. And that's given here. Now we know that, well, let's go ahead and plot this first. Okay. This is X and this is Y. And let's do this. This is a scatter plot. Okay. So let's move the plot here. This is the plot that we saw in the PowerPoint. Okay. So this is, now we need to format the graph. Sales 100K. Okay, we'll put a dollar in front. Okay, and then we'll check this axis title and include x-axis. So that would be area payroll 100 million. And this is annual sales. We'll put that here as well. All right. So now we have a scatter plot, and you can see in the scatter plot there is a kind of a linear relationship between these two variables. In fact, Excel allows you to plot a trend line. Okay, so you can choose a trend line here. If you click this arrow, you're allowed several different possible trend lines, exponential, linear forecast, and so on. And also you can fit polynomial. Okay, but we'll stick with linear, and it also so Excel allows you to display the equation in chart too. Okay, so if you click that, then the regression equation will show up. Okay, we'll move it here. Okay, so this is what we're going to develop, these numbers. Okay, so we'll come to that in just a minute. Okay. Now, to find b sub 0 and b sub 1, okay, we have to find these columns. We have to set up these columns. We have the formula here. Okay, right? So we need to set up columns to compute all of these sums. So you need x minus x bar, y minus y bar, square them, and on and on. So, which means you have to first find the average. So let's do average. Okay. So that's our average. So that's average of x, right? And then we have average of y. So now x minus x bar, so take x minus x bar is here, and we have to absolute reference that. So that would be x minus x bar, and we want to square that. Okay, so that's for the denominator. See, the denominator, we have x minus x bar squared. So we'll need that. Then we need y minus y bar. Y minus, that's y bar. Okay, absolute reference that. Okay. We don't need y minus y bar squared for these formulas, but we will need it later on. So we'll come back to that later. Right now, all we need is x minus x bar times y minus y bar. Okay. All right. So let's copy these down. Okay, up to that. Okay, so let's put a border. Now we need the sum. Okay, that's an average, so we need a sum here. So sum of that, we need sum of that, and we need sum of that. All right. So now we can apply, we're ready to apply the formula. So sample size is, we use count. We need to use formulas all the time. Okay, so don't just type in numbers. X minus x bar squared, sum of x minus x bar squared is that. Okay, sum of x minus x bar times y minus y bar is that. Okay. Now x bar is that and y bar is that. So now we have assembled the summary data from the table up there to here. So now we can set up the formula. So b sub 1 is, that's the numerator, right? Divide by the denominator. So that gives you 1.25, which is what we saw here, the coefficient for x, the slope. An intercept is y bar minus b sub 1 times x bar. Okay. So that's 2, which is what we see here. Okay. Now Excel gives you built-in functions which we can use to find the values of b sub 0 and b sub 1 without having to go through all these rigmarole. So b sub 0 is intercept. So if you say intercept, and then you have to provide the y range first. So y range is that, comma x range. All right. So this function will work only for simple linear regression. If you have more x's, then this won't work. So that's your intercept. And then slope, the function for slope is slope. Again, same, y first, and then x. So then we can set up the y hat. Y hat is our estimate for y. So that would be, we can write that as 2 plus 1.25x.